Let us look at proposition number 15 of book 12 of Euclid's Elements. The proposition says, in equal cones and cylinders, the bases are reciprocally proportional to the heights. And those cones and cylinders which are where the bases are reciprocally proportional to the heights are equal, which means that if I change the radius of the second cylinder, if I increase the radius, the height will reduce to maintain the equality of the volumes. If I increase the height, the radius will reduce. So that is what is meant by reciprocally proportional. Okay, let's see how we can prove this. Given equal cones and cylinders, we will look at the cones later, with the circular bases ABCD and EFGH, AC and EG are the diameters of the bases, KL and MN are the axes which are equal to the height of the cylinders. What the proposition is saying is that in equal cylinders AO and EP, base ABCD is to base EFGH is equal to height MN is to height KL. That is reciprocally proportional. Now, there are two cases here. One where the heights are same for both, and the other case is when they are unequal. So let's make them equal and see how we can prove in that case. So let me increase the radius so that the height reduces. And let's say now the heights are equal. So height is either equal or unequal. So let's take the case of heights are equal. Cylinder AO is to cylinder EP as base ABCD is to base EFGH. We know cylinders are proportional to their bases. Now, since cylinder AO is equal to cylinder EP, that means bases are also equal. Base ABCD is equal to base EFGH. And reciprocally, we can say base ABCD is to base EFGH is equal to height MN is to height KL. Because cylinders are equal, bases are equal, and heights are also equal. Okay, now let's look at the second case. And let Mn be greater than KL. So let me make it greater. Now, what we do is we cut Mn at a point such that, and let's call that point Q, Qn is equal to KL. So let's cut it off. So here Qn is equal to KL. Let the plane SU cut the cylinder through Q parallel to the planes PR and GE. So let me bring in that plane and let's name points on that. So SU. So we have a plane SU which is cutting the cylinder parallel to PR and GE. Now we are given that cylinder AO is equal to cylinder EP. So cylinder AO is to cylinder ES as cylinder EP is to cylinder ES. Let me color these cylinders differently so that we can distinguish it. Okay. Now, how did this proportionality come? Because AO is equal to EP. So, which means ES is the same fraction of both AO and EP. So we can say cylinder AO is to cylinder ES is equal to cylinder EP is to cylinder ES. Cylinder AO is to cylinder ES. AO is to ES as base ABCD is to base EFGH. Because cylinders are proportional to their bases. And cylinder EP is to cylinder ES as height Mn is to height Qn. Why? Because if a plane cuts a cylinder, then the cylinders are proportional to their heights or to their axis, and here axis is equal to height. So now what do we have? We have cylinder AO is to cylinder ES. Cylinder EP is to cylinder ES. But AO and EP are equal. That means the left-hand side ratio of both these statements are the same. That means the ratios on the right-hand sides will also be same. So base ABCD is to base EFGH is equal to height Mn is to height Qn. But Qn is equal to KL. So base ABCD is to base EFGH is equal to height Mn is to height KL, because it is equal to Qn. This is what we had to prove. Base ABCD is to base EFGH is equal to height Mn is to height KL. Now, the proposition also says that given cylinders AO and EP such that the bases are reciprocally proportional to the heights, then cylinder AO is equal to cylinder EP. So we are given that the bases are proportional, reciprocally proportional to the bases. Height KL is equal to height QN. Base ABCD is to base EFGH is equal to height Mn is to height Qn, because Qn is equal to KL. But base ABCD is to base EFGH is equal to cylinder AO is to cylinder ES, because the heights are same. Height Mn is to height Qn is equal to cylinder EP is to cylinder ES. So we are looking at these two cylinders, the overall cylinder EP and this cylinder. Now here base is same. So if bases are same of two cylinders, then the cylinders are proportional to their heights. Here base ABCD is to base EFGH is equal to height Mn is to height Qn. Okay, so which means base ABCD is to base EFGH is equal to cylinder AO is to cylinder ES. And height Mn is to height Qn is equal to cylinder EP is to cylinder ES. So that means we can write this proportionality. Cylinder AO is to cylinder ES as cylinder EP is to cylinder ES. Which means what? Both cylinders AO and EP have the same ratio with cylinder ES. That means cylinder AO is equal to cylinder EP, which is what we had to prove. And similarly, we can do it for the cones. So we would build this cone, and this cone. So I leave it with just this statement. Similarly, in the case of the cones, just as Euclid did. So that is proposition number 15 of book 12 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.